Welcome back again in my YouTube channel. It's Nekomat Senpai. In my previous video, we discussed sampling distribution of the sample means. This time, you're going to compute its mean and variance. Objective: find the mean and variance of the sampling distribution of the sample mean. Take note of the following formulae needed to compute the mean, variance, and standard deviation of a population, or the sampling distribution of sample means. Let us have an example. Consider a population consisting of the values 2, 3, and 4. Actually, I used the example in the previous video in sampling distribution of the sample means. This is the population. So you are going to compute the population mean, variance, and standard deviation. Then after that, you're going to list all the possible samples of size 2 with replacement and their corresponding means. We actually did it in the previous video, so we're just going to copy. Then after that, you're going to find the mean, variance, and standard deviation of the sampling distribution of sample means. So we are going to compute first the population mean. We already have the formula here. We have here mu. This is a Greek letter that represents the population mean. You have here the sigma notation that represents the sum. You have your x, the elements of your population, and you have here big letter N that represents the entire population or the number of elements in your population. So you're going to add the elements in your population. So you have 2, 3, and 4 divided by the entire population. So you have 2 plus 3 plus 4 divided by, there are 3 numbers, so there are n equals 3. So you add this, you have 9 divided by 3. That means the population mean is equal to 3. Okay, next is to compute the population variance. So I have here the table. So you're just going to fill in this table. First column is you have the elements of your population. So your population is consists of 2, 3, and 4. So we're going to write here 2, 3, 4. And this row, I'm going to leave that for total. Because we're going to get the sum of the square of x, the difference of x and a population mean. Okay, next is you subtract the x and the population mean. So remember our population mean is 3. So we're going to subtract 2 and 3. That is negative 1. You have 3 minus 3. That is equal to 0. And you have 4 minus 3. That is equal to 1. Okay, next. So from here, from the second column, you're going to get its square. So you already know how to get the square, right? So if you have here negative 1, okay, raise that to 2. That becomes negative 1 times negative 1. So the answer is positive 1. You have 0 squared, that's 0. 1 squared is 1. Okay, next is you're going to, based on your formula, you need to get the sum of this. Okay, so that's why I leave a row here. So you're going to get its sum. So you have 1 plus 0 plus 1, so that is 2. Okay, we're going to substitute that in our formula. So this is the formula for population variance. This is the symbol for population variance. This is sigma in small letter. Okay, so the sum is 2 divided by the entire population. So you have 3. So 2/3. Okay, so you can write that as decimal. So that becomes 0.6666. Okay, repeating, right? So we can just round off that to 0.67. Find the population standard deviation. In our previous slide, we already solved the population variance. Now to get the standard deviation, you just need to extract the square root of the population variance. So in that case, the sigma squared becomes sigma. And you're just going to substitute the value from in this. Okay, so you have 2/3, right? And we round it to 0.67. Okay, but we're just going to write this as 2/3. Okay, so that the answer that we will get is not that far from the real value. So what is the square root of 2/3? So in your calculator, that is 0.816. Okay, so we're just going to round off to 2 decimal places. So that's 0.82. This is your population standard deviation. List all the possible samples of size n equals 2 with replacement and their corresponding means. So what I did is just copied the table from the previous video because I told you that this is the same example. Find the mean of the sampling distribution of sample means. I copied the table from the previous slide so that we have our guide here in getting the sum. And you have here the formula for the mean. So you have mu sub x bar that represents the mean of the sampling distribution of sample means. You have here sigma that represents the sum. And you have your x bar that represents the sample means. And the small letter n that represents the sample size. So what you're going to do is just get the sum, then divide it by the sample size. So you add all these values here. So the sum is 27 divided by the sample size is, there are 9 samples, so you have 9. 27 divided by 9 is 3. So the mean of the sampling distribution of sample means is 3. Find the variance of the sampling distribution of sample means. So I have here a table. I just copied it from the previous slide again, but added some columns in which will guide us in solving the variance. So based on our formula, so you need to get the average of the square of the difference of sample mean and the mean of the sample mean divided by the sample size. So in our third column, we're going to subtract the sample mean and the mean of the sample mean. Okay? From the previous slide, we already know that the mean of the sample mean is 3. Okay, so we're just going to substitute that here. So the mean here in the first row is you have 2, okay, minus 3. Okay, we get this from here. So you have here negative 1. Next, you have 2.5 minus 3. You have negative 0.5. And you have 3 minus 3, that's 0. you have 2.5 minus 3, that's negative 0.5. 3 minus 3, you have 0. I'll just write it right away. Then 3.5 minus 3, that's 0.5. Then 3 minus 3 is 0. 3.5, same. And 4 minus 3 is you have 1. Okay? So these are now the difference. After that, in the last column, you need to get its square. So you have here negative 1 squared, that's 1. Negative 0.5 squared, that's 0.25. 0 squared is 0. Negative 0.5 squared, you have the same answer in the second row. This is 0, this is 0.25, 0, 0.25, and 1. Okay, so we're going to get now the sum. Now you have here the sigma notation that represents the sum. So you add all these values here, then divide it by the sample size. So you have 1 plus 0.25 plus 0.25 plus 0.25 plus 0.25 plus 1. Okay, what is the total or the sum? So that is 3 divided by, what is your sample size? So sample size is 9. Okay, so 3 divided by 9, that is, this is the variance, okay? So that's 1/3 if you're going to simplify, or in decimal number, that's 0.33. Okay, with a bar there, that means it is repeating. Last is you're going to find the standard deviation of the sampling distribution of sample means. So again, the formula for the standard deviation is the square root of its variance. So you just substitute the variance that we got from the previous slide. So you have 1/3, right? So get the square root of 1/3. Okay, I'm using my calculator here. The answer is 2 decimal places, that's 0.58. We have here the table showing the summary of the results that we got in computing the mean, variance, and standard deviation of the population and the sampling distribution of sample means. Now, what have you noticed? In the first row, you can see that the population mean and the mean of the sampling distribution of sample means are equal, right? How about its variance and standard deviation? Okay, so we have here the properties of the sampling, the mean and variance of the sampling distribution of sample means. This situation is when you have repetition or there is a replacement. So first you have the mean of the sampling distribution of means is equal to the mean of the population. So you have the mu sub x bar is equal to mu. The variance of the sampling distribution of means is equal to the population variance divided by the size of n of the samples. Okay, that is given by this formula. Okay, so if you want to check, we can substitute our given. So that is equal to the population variance, you have 2/3 divided by, it says here size of n of the samples. So remember that your population consists of 2, 3, and 4, and we're going to take a sample size 2. So divided by 2. So you can do cross multiplication, or no, you get the reciprocal. Alright, reciprocal of this. Then change this to multiplication. So you have 2/3 times, this is 1/2. So you cancel. So what remains is 1/3. So this is correct. Okay, how about the standard deviation? The standard deviation of the sampling distribution of means is equal to the population standard deviation divided by the square root of the sample size of n of the samples. Okay, and that is given by this formula. So population standard deviation is you have 0.82 divided by, okay, this is the same with the variance. Your n is 2, so you have square root of 2. So using your calculator, if you have your calculator there, so you check. So 0.82 divided by square root of 2. Okay, the answer is 0.58, round up to 2 decimal. This is correct. Okay, how about when there is no replacement? For without replacement, these are the formulae, so take note of this. I didn't give an example, but maybe soon in my next videos I will give examples. Okay, hope you learned, and thanks for watching.